In the race into space, while the United States set its sights on the moon, the Soviet Union chose a very different path. It launched an ambitious program focused on Venus, known as Venera. The first signals sent back delivered shocking information. Surface temperatures on Venus reached around 475 degrees Celsius, hot enough to melt lead, while atmospheric pressure was about 92 times that of Earth, an environment far more extreme than anything previously imagined. After a long series of failures, the Soviet Union achieved something unprecedented. From grainy black and white images transmitted from the planet's surface to the first color photographs from Venera 13, humanity saw sharp, jagged rocks and a searing orange sky. For the first time, we heard the sound of howling winds from another world. Data collected by the Soviet Union over more than 2 decades fundamentally transformed how we understand the universe. Could this be the future of Earth itself? What did the Soviet Union truly discover on the surface of Venus? Venera 13, launched in 1981 and successfully landing in March 1982, marked the pinnacle of the entire Venera program. The moment Venera 13 touched down, the countdown began under those conditions. Any technical failure would have meant permanent silence. Against all expectations, the spacecraft did more than transmit a signal. It operated continuously for about 127 minutes, nearly 2 hours, a human-made machine surviving and functioning on the surface of Venus exactly as designed. In the history of planetary exploration, this was a record. The first data sent back were not numbers, but images. For the first time, humanity saw the surface of another planet in true color photographs. Not illustrations, not radar-based inference, but light that had struck rock, passed through the atmosphere, and been captured. Venus's surface appeared littered with jagged, sharp-edged rocks scattered across hardened ground. The entire scene was bathed in a deep yellow-orange hue, as if the sky itself were on fire. This was the physical result of a dense, CO2-rich atmosphere, where sunlight is scattered so intensely that it nearly loses all direction. One detail that particularly caught scientists' attention was the absence of clear shadows. On Earth, light coming from a defined source always casts shadows. On Venus, light seemed to arrive from every direction. This revealed that the atmosphere was not only thick, but functioned like a massive diffuser, blurring the boundary between day and night, between light source and object. Venus does not have a blue sky, it has a heavy dome of light. Venera 13 did not stop at observation. A mechanical drilling arm was deployed, penetrating the rock beneath the surface, marking the first time in history that humans directly drilled into the surface of another planet. Analysis showed that the primary material was basalt, a product of rapidly cooled volcanic lava. Basalt is evidence of intense volcanic activity, of a planet that once possessed significant internal heat and continuous surface renewal. Venus is not a static rock scorched into stillness. It is a world that once moved, transformed, and perhaps has not entirely fallen asleep. Then came a moment few expected from a planetary mission. A microphone aboard Venera 13 recorded faint vibrations in the surrounding environment. Not a violent roar, but gentle winds brushing across the surface, subtle tremors as metal components of the lander contacted rock during drilling. These sounds may seem insignificant to the human ear, but scientifically, they were decisive. They confirmed that Venus's atmosphere, despite being dense enough to resemble a fluid, still moves near the surface. This planet is not frozen in absolute silence. Venus is not only hot and high pressure, it is a system where atmosphere, terrain, and internal energy constantly interact. Data from Venera 13 revealed a surface undergoing intense chemical weathering, shaped by long-term exposure to a CO2-rich atmosphere laden with sulfuric acid. This is the result of a runaway greenhouse effect, where heat has been trapped uncontrollably for hundreds of millions of years. If Venus once had water, once possessed more temperate conditions in its distant past, what drove it to its present state? When a planet nearly the size of Earth, with similar material composition, ends in a permanent inferno, how fragile is the safe boundary for truly Earth-like worlds? The color, images, geochemical data, and even those faint sounds transformed Venus from a temperature chart into a world with a voice. But to fully understand that voice, humanity must return to an even earlier moment, the moment when the first spacecraft transmitted images from this planet's surface, even if they were only rough black and white frames. It was there that humanity's perception of Venus truly began to change. Before Venus was seen in blazing color and heard through the faint vibrations of wind, it first revealed itself to humanity in stark, cold black and white frames. In 1975, with the successful landings of Venera 9 and Venera 10, The Soviet Union achieved a milestone that had previously existed only in theory, capturing images directly from the surface of another planet. Not the moon, not a body humans had set foot on, but Venus, an uninhabited world where every physical condition works against the survival of machines. Those first images were constrained by the data transmission technology of the 1970s, by the lander's brief lifetimes, and by Venus's own extreme environment. Yet it was precisely this rawness that made them authentic. This was real light striking real rock, reflecting through a dense atmosphere and becoming distorted before reaching human sensors. The first surprise was not the terrain, but the light. The images showed that Venus's surface was not shrouded in darkness, as many had imagined. Sunlight still reached the ground, even after passing through an extraordinarily thick atmosphere, where pressure is about 90 times that of Earth, and cloud layers extend to nearly 80 kilometers in altitude. Yet that light cast no clear shadows. There was no familiar direction to illumination. Objects appeared evenly lit from all sides. The reason lay in intense scattering within a CO2-rich atmosphere filled with sulfuric acid cloud particles, turning the entire Venusian sky into a vast light diffuser. This effect forced scientists to rethink how solar energy interacts with a planetary atmosphere. On Venus, light itself becomes an environment where human evolutionary intuition no longer applies. Looking down at the surface, images from Venera 9 and 10 revealed relatively flat terrain, scattered with angular rocks, and showing no signs of water erosion. There were no dry riverbeds, no layered sediments, no evidence of oceans or long-lasting rain. Instead, the rock formations bore the unmistakable signature of volcanic activity. Subsequent analysis combining imagery with geochemical measurements confirmed that the landing sites were dominated by basalt and solidified volcanic ash. Basalt is not an unfamiliar material on Earth. It forms when lava cools rapidly and is typically associated with large lava flows and intense volcanic activity. Finding basalt on Venus carried deep implications. The planet once possessed substantial internal heat and an active geological history. It was not a world that died in its infancy. On the contrary, Venus was once violently active, a planet whose surface may have been repeatedly reshaped by global-scale volcanic eruptions. The relative flatness of the terrain also suggests that Venus may have undergone episodes of surface resurfacing, where lava flooded older structures, erasing evidence of earlier geological processes. This stands in stark contrast to Earth, where plate tectonics creates fragmented and diverse landscapes. Through those first images, Venus emerged as a planet where internal energy was released in unfamiliar ways. In 1975, these conclusions posed a serious challenge to existing planetary models. Many hypotheses at the time still viewed Venus as a geologically frozen planet, where internal processes had long since ceased. But the black and white frames from the surface told a different story. They revealed traces of a hot, violent, and prolonged past, one whose consequences remain etched into every rock. If a planet can be transformed this profoundly by atmospheric and energy imbalance alone, then where does Earth's safe boundary truly lie? The images sent back were the final signals, just before Venus reclaimed all of that space for itself. Venus is not only uninhabitable, it is a place where physics reaches such extreme states that even the most advanced engineering achievements of the 20th century are pushed to failure. Here, machines break down because the planet itself allows no compromise. The Venusian atmosphere is the direct agent of that destruction. Unlike Earth, where the atmosphere is thin and plays a regulating role, Venus's atmosphere is a massive, crushing envelope that engulfs the entire planet. More than 96% of it is carbon dioxide, with most of the remainder being nitrogen, along with traces of sulfur dioxide and water vapor. Higher up, from roughly 45 to nearly 80 kilometers in altitude, dense cloud layers filled with sulfuric acid blanket the planet, reflecting much of the incoming sunlight while simultaneously trapping heat with near-perfect efficiency. Beneath those cloud layers, pressure rises rapidly with decreasing altitude. At the surface, it reaches about 90 to 92 atmospheres, equivalent to the pressure nearly 1 kilometer beneath Earth's oceans. In this environment, air no longer behaves like a normal gas. It exerts continuous compressive force on every surface, every seam, every joint. Surface temperatures on Venus, meanwhile, remain remarkably stable, with little difference between day and night. At such temperatures, many metals begin to lose their mechanical strength, welds weaken, and electronic components, no matter how well shielded, inevitably move toward irreversible failure. Against this backdrop, Venera 7 became a remarkable milestone. In 1970, during its descent, the spacecraft's parachute system malfunctioned, causing it to fall freely onto the Venusian surface at an estimated speed of about 61 kilometers per hour. By conventional engineering standards, this impact should have completely destroyed a delicate scientific instrument. Yet, what astonished scientists was that Venera 7 did not fall silent immediately. After impact, it continued to transmit a weak signal for more than 20 minutes. Those signals, brief and incomplete as they were, provided the first direct measurements of surface conditions on Venus. After Venera 7, each subsequent Soviet lander incorporated significant improvements. What makes Venus truly terrifying is its ruthless stability. On Earth, machines often fail because of unexpected events. At such temperatures and pressures, liquid water cannot exist on the surface. If Venus once had oceans in its distant past, they vanished long ago. Water vapor, rising into the upper atmosphere, was split apart by solar radiation. The lighter hydrogen escaped into space, leaving oxygen behind to react with the surface and other compounds. The water cycle collapsed, locking the planet into an irreversible greenhouse state. The wrecks left behind on the surface of Venus, slowly heated and deformed over time, have become silent markers. They define the boundary that current technology cannot cross, while reminding us that science does not advance through uninterrupted victories, but through confronting failure and extracting meaning from it. Venus does not destroy machines senselessly. It forces humanity to understand planetary science more deeply: climate, atmospheres, and the fragile limits of planetary stability. When machines can no longer continue observing, science is forced to stop at the boundary between what is known and what cannot yet be confirmed. And from that blurred boundary, decades of debate have emerged. Debates centered on a fundamental question: which signals are real and which are merely illusions cast by a planet that has crushed every instrument sent to observe it? Throughout the Venera era, Venus was commonly viewed as a hot, dry, waterless world, lifeless and essentially geologically frozen in its final state. The measurements collected by the Soviet Union fully supported that picture. But those data reflected only the end result, not the process that led there. In the 1990s, NASA's Magellan orbiter accomplished something Venera never could, mapping the entire surface of Venus using high-resolution, cloud-penetrating radar. Those radar maps revealed that Venus does not resemble an ancient planet worn down over billions of years. Instead, much of its surface appears geologically young. Vast basalt plains, lava domes, and massive volcanic structures appear in dense concentrations. Even more telling, there are very few signs of old impact craters, suggesting that Venus's surface may have been resurfaced on a global scale in the relatively recent geological past. This lay completely beyond the reach of scientific understanding during the Venera era. When landers survived only tens of minutes to a few hours, scientists saw flat terrain, but could not recognize that this flatness was the signature of a planet that had been almost entirely renewed. Another layer of insight comes from the atmosphere. Venera measured Venus's atmospheric composition with impressive accuracy. But science at the time lacked the tools to understand its long-term dynamics. The Soviet missions detected sulfur dioxide, yet could not see the deeper connection between the atmosphere and the planet's interior. The most important thing the Soviet Union could not perceive lay even deeper and carried existential weight. Venus may once have been a very different world. Modern planetary climate models suggest that early in the solar system's history, when the sun was weaker, Venus could have had far more temperate conditions. Venera measured the consequences of that divergence, but could not observe the moment when the system slipped out of balance. Another paradox lies at altitudes around 50 to 60 kilometers in Venus's atmosphere. Modern data show that at this level, temperature and pressure are closer to Earth's surface conditions than anywhere else on the planet. The surface is hellish, yet above it exists a physically comfortable atmospheric layer. The Venera missions were not designed to study this region in depth. The Soviet focus was the surface, where the greatest challenge lay in pressure and heat. Yet, it is precisely this middle atmospheric layer that may hold the key to understanding Venus's climate history and how it lost the ability to sustain water. In the end, what the Soviet Union did not realize was not a scientific failure, but the scale of the lesson Venus had to offer. They approached the planet as a technical challenge. Could humans place machines in the most extreme environment imaginable? What the Soviet Union discovered on Venus revealed a brutal reality. A planet dominated by temperatures and atmospheric pressures powerful enough to crush even the most resilient mechanical structures ever built. Through the Venera program, humanity gained not only the first direct visual evidence from the surface of another planet, but also hard proof of an atmospheric system locked into a runaway greenhouse effect. The overwhelming presence of carbon dioxide and winds saturated with corrosive acids stands as clear testimony to a path of planetary evolution that runs completely counter to the conditions required for life. Although they survived only a few brief minutes before being destroyed in that inferno, Soviet landers left behind a scientific legacy of extraordinary value. Venus is no longer a distant mystery. It has become a vast natural experiment, a stark warning about the fragile limits of a planet's biosphere and the future that awaits when environmental balance collapses. The Soviet legacy on Venus is a lesson written in extremes, one that modern science can never afford to forget. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.